This whole project is divided into subsystems so that we can each focus on something in particular. And like you said, we're the propulsion subsystem. So really what we're focusing on is the lift power that is going to both give us a controlled landing on the moon and lift us up off the moon and to land again, because that's basically what we're doing here. So there's a lot that goes into that with regards to how the rocket functions, how each one of the rockets, the engines function, how much power they get, how much thrust, and ultimately how the fuel works and how it translates into thrust. So that's in general what we're focusing on.
Part of the reason that everybody is excited with the new space movement and companies is that they're able to do things for order of magnitude cheaper than traditional aerospace companies or governments have been able to do. For example, SpaceX developed the Falcon 9 rocket for a cost of around $300 million, where NASA's own estimates for a comparable launch vehicle, they estimated it would cost them $4 billion. So that's an 11-fold reduction in price. Part of the way that you can achieve those types of cost reductions is looking for non-traditional ways to achieve your goals. And we had a prototype craft with a hexcopter that we were building before we decided to transition to a quadcopter. And we were making this with some traditional methods using considered lightweight materials like fiberglass. However, just one of these arms weighs about 350 grams. So, and one of these plates does too, and there's 2 of them. So we have a significant amount of weight here, and we required 6 motors to lift this up. When we transition to a quadcopter, initially we're going to take this design and try to have 4 arms on it. Right here is the model of that JP was discussing about how this allows us to take a simplified thing before we achieve free flight. But this whole structure, the part that's actually going to be flying, which is just from here up, is about 700 grams. So for the weight of 2 of these arms, let alone the panels, we can have our quadcopter. And so that's a lot lighter, and we're able to manufacture this in a day rather than this, which had to take several cutting processes. We had to use a water jet cutter to get all these holes and everything else. That computer files had to be made, so we had to program the water cutter, and this was a pretty intensive process that it took maybe a week to produce something like this, and then it took about a day to produce that. So those kind of order of magnitude reductions in time and costs are going to allow us to do this lunar mission for an order of magnitude or 2 cheaper than traditional governments have done in the past.
Controls, they are the ones in charge of, we're going to put a sensor either up here or on the bottom, depending on where we decide to put it. And it will basically be measuring how this is tilted, how this is moving, how fast it's moving in each direction, and it will calculate, it'll figure out how to best correct whatever is happening. So I think Michael was saying earlier that if it gets knocked to this side, the sensors will be able to tell. There will be gyroscopes and accelerometers and magnetometers, and all 3 of those together will be able to tell how fast it's going that way, how much it's tilted that way, and it'll be able to say, okay, let's turn this one to go faster, turn this one to go slower, and so this will lift more, this will go down, and it'll steady itself again. So that's what the control system is doing. We're actually trying to get this at least flying level and steady by the end of the month.